Hello and welcome to TidyX episode 115. TidyX is a screencast where we go through and explain how our code works. My name is Ellis Hughes.
And my name's Patrick Ward, and we're back. Can you believe it?
We're back. It's been a
It's been
minute since
a
Patrick has been able to
yeah.
record. Been a little
I've come up
busy.
come up for air. So
but
here we go. We're back. It's been
we're
2 weeks.
jumping right back into what we were talking about, I feel like a month ago at this point, which is talking about how S4 objects work, how we create them, and how we can actually use them.
Yeah.
And before we really dive in again, I saw a Twitter thread earlier this week, and I thought it was relatively relevant to what we're talking about right now. So I'm gonna make our videos a little bit smaller. But this is a tweet from Danielle Navarro talking about S3 methods, and I just think this is so funny. And the quote is, it's a screen capture going the dot is typically used to denote an S3 method in R, but because R embraces chaos, this is not universally adhered to. And in any case, S3 is, anyway, it continues on. But it ultimately goes to say, like, it's a super powerful programming system, S3 is, but it allows you to shoot yourself in the foot. And that's totally true. I love S3. I love the chaos. I'm a weirdo that I am a dirty gremlin when it comes to programming at times, where I love the flexibility that it gives me to just change things on the fly as I'm going. I mean, you can always go back and update an S4 object, for example, but the S3 flexibility that it gives me as I build out packages and whatnot, I really enjoy that. I mean, ultimately, out to the user, everything is controlled and nice, and they don't have to worry about those things. But as a programmer and doing what I do, I like that. It gives me so much flexibility. But some people don't like that. Some people that come from other much more strict programming languages where they don't have something like the S3 object system where they can just absolutely send it, and they need to define everything. Going to an S3 object system feels like chaos. And so I can sympathize with that. And so let's talk a little bit more about S4 and how we can actually use it. So let me close that there. So we're going to do what we did for S3. So in S3, after we taught you kind of the super basics of how you might create an S3 object, we went and go, okay, now how might we actually use an S3 object? What's the, like, why would he use this? And so we're going to go through the same exercise, but with an S4 object, and kind of taking some of the feedback that you all gave us, incorporate additional pieces to it that'll hopefully help explain more fully the benefits and also demonstrate more places where you could use an S4 object. And so the general problem statement that we have is we're a data scientist at a sports betting company, a local one, and the season just ended for a local sports league, and we want to predict who's going to win the tournament that happens at the end of the year. We've already done analysis of the team, so we already know, like, the strength and standard deviation of the teams themselves, so we already have that, and it's kind of related to stuff we've done in the past with Bayesian modeling. But the first thing we do before you go to simulate the full tournament is simulate a game. Let's simulate how can we predict who's going to win a game and give us, like, relative percentages of that. So the first thing we're going to do on our journey of simulating a first game is defining a team. And so we're going to create a new S4 class called team using the set class function that takes realistically just needs 2 arguments, but we're going to provide 3. Class, and so we're going to say the new class we're creating is team. The slots, these are the types of objects that I can put into my S4 object at specific places. So we have a slot for team, a slot for strength, and a slot for standard deviation. The team slot can only accept a character, the strength slot can only accept a numeric, and the SD slot can only accept a numeric. And then we pass prototype. Prototype is where you define, these are the values. If I don't give you a value, drop this in. And so what I've done here is I've defined, if I don't pass strength or standard deviation into this object, give this team a strength of 0, and if I don't give it a standard deviation, give it a standard deviation of 1. I figured that was a relatively safe kind of blah situation. If for some reason,
Yeah.
if we were to be using this on a bigger situation, this would like not give them a, it wouldn't look real.
You know where this would be kind of interesting, because you already mentioned like some of the things that we've done with team strengths and base analysis was you could actually put in there your priors, your prior strengths for the average team, and have a basically play out an entire season of sports where you regress the teams after each game to the prior until a certain point in the season where you no longer need to regress to the priors because you've seen enough data to know how strong that team actually is. But this would be a way that you could use something like that in order to sort of normalize the team strength.
Exactly. Yeah, that's definitely something we could do. Yeah. So then I create this function called new team. So new team, left assignment operator from function. It takes the same 3 arguments that we'd have before: team name, strength, and standard deviation. But this is kind of a nice wrapper around the new function. So that we need, in order to create a new object that has a class team, we need to use the new function, and we set the team strength, or the team name, strength, and standard deviation. And I like just doing this because it feels a lot nicer to use. And then in addition, it allows, like if you're using RStudio, for example, and now that I have the new team function defined in my environment, it will give me prompts for what I need to enter in. If we were just trying to do this with new, it's kind of not helpful. And so I like creating wrapper functions like this so that I can just do autocomplete, and it makes my life easier. Okay, so now we've got a function that's going to create those teams. So we're going to create, I think this is 8 different teams. So the Jayhawks, Chicken Hawks, River Hawks, Gray Hawks, Orange Hawks, Hockey Talkies, and Hawkeyes. Completely random names, don't actually represent anything in particular, but we're giving them their team name and then a random strength and standard deviation. So how strong are they on average, and then how much do they like vary in their strength. So like one team could be pretty strong like the Hockey Talkies, but their variance is very high. Or they could be like a medium to low end team like the Orange Hawks, but they don't vary all that much. So it's always possible that the Orange Hawks could beat the Hockey Talkies if the Hockey Talkies have a bad game and the Orange Hawks are like slightly above their average.
Yeah, totally made up values and strengths, and we'll get silly results because this isn't real. But
yes, exactly.
But it works for purposes of example.
Yep. And then we're gonna have, so now we've got our teams. Now we need to predict how that team performed in an actual game. And so we're going to use simulation to do this. And this is the exact, or a very similar function that we used during our S3 examples. The difference keen eyes might see is that rather than using a $sign, we're using the @ symbol because we're accessing the slot of strength in our team object. We're no longer accessing it using a $sign because it's no longer a list. It's a S4 team class. And so this will look and feel the exact same as it did before. So it predict team performance. It takes object and nsims. It throws it into an rnorm function. So random sampling normal from a normal distribution. We're going to pull nsims out of that distribution with a mean of strength and standard deviation of standard deviation. So yep, it behaves exactly the same. This is how we get 1,000 samples from there. This is how we get 100 samples from there. 1 sample from there. It's how you'd expect it. But now now that we can say how a team performed in a specific game, we need to say, okay, now how do they perform against another team and actually run a team? And so one suggestion that people gave us, and we're taking this on, is we just returned the winner. So we just returned the object that contained the team that won.
Yeah, a text string.
Yeah. We thought it would be nice, and so did some of you, that we actually store all the information from that simulated game in an object. I'm like, oh, that's actually a pretty good idea. So let's do that. So this is different now from what we did for S3. So we're going to create a new class, a new S4 class called Game Results. It's going to take 4 slots. It's going to take Team 1, Team 2, so the 2 teams that play each other, predicted results, and we're going to say that's a data frame. Oh, so I guess here too, this is kind of cool to see how you can build up your objects over time. So we're saying that we're going to accept a team object for Team 1 and Team 2 only. So it can't be like a string, it can't be a random value. It must be a team object that we defined earlier on in the script. So that's kind of how you can build up your systems. Then we're going to take predicted results, which will accept a data frame. And then we're going to pass the seed, because now we're actually going to record the seed of the random numbers so that we can use that in the future. We're going to make a nice show method, which is like the print method. And so for game results, it'll print out this is the team versus this team, so the team names that played each other. We're going to get the winner team object and pull out their team names when we record which team won, and then we're going to get the win percentage of the winning team. And so this is going to vary obviously based on whichever team was the actual winner. But you may note that get winner and get winner percent are not actually real functions at this point in time. They don't work. And so we're now going to have to go and create our own methods for or our generics and methods for our game results object to pull those values out for us. And so the way you create a new generic in S4 is you use the set generic function. You're going to say, okay, we're going to have this function. It's going to be called get winner. It's going to accept an object, and we're going to grab the generic or grab the method based on the class of object that exists. So it's kind of weird because we're calling get winner twice here, but all this is telling R is figure out based on object what class object is, and then find the method get winner that matches that object class. It's really fun. It's really weird. But basically what's happening is it's going to call this function because I'm saying that I'm adding this method get winner, and it's going to work for objects of type game results. And so when I call get winner, it's going to look for the method get winner that works for game results. And then it's going to go through and calculate which team won by looking at our data frame that contains our predicted results and go, okay, is it team 1 that won? Did team 1 win more games than simulated games than team 2? If so, then yes, team 1 is the winner, therefore return team 1. If team 2 won more, return team 2. It's pretty straightforward. And then get winner percentage, same sort of idea. We're creating another generic called get winner percent. It's going to, when you call get winner percent, look to see if there's a method assigned to game results. And then because we're creating that right here, of course that will exist. So it helps if I do that first. And it's going to go through and figure out the win percentage, and basically it'll calculates the winning percentage for team 1. If team 1's winning percentage is greater than 0.5, that it returns team 1, and if it's less than 0.5, it subtracts that from 1 to give us team 2, because it's a zero sum, right? If one team wins, the other team loses, and vice versa.
Yep.
So that's simple there. And so now we can see that get winner percent is an actual function, as well as get winner. Would you look at that? So this has been a fair amount of setup, and we're not quite done yet. So we're going to have run sim game, which is the name of the same function that we used last time for S3, and it takes the same arguments, team 1, team 2, and then sims, and now we've added this seed into there, We're not quite using it yet, but whatever. Here, actually, I should add that in. Set.seed seed. So now we can replicate our results. And so this is going to run this in game. It's going to set the seed. It's going to simulate team 1 and team 2 and put that into a data frame called sims. And then we're going to create a new game results S4 object that has team 1, team 2, the predicted results, and the seed. So all the information we need to look at the game. So we're going to run that. And now, as per usual, this is going to look and feel like the S3 situation that we did before. Oh, what's going on here? I did not run the show there. So now we have the show method for this. So now when we print that, it prints out all pretty and nice. So we ran the Jayhawks versus the Chicken Hawks. The winner was the Jayhawks, and they won 61% of their games.
So that's pretty cool. That's what our S3 looked like.
Yep.
But what about all that other stuff that's stored in there?
Yep. So
how can we look at that?
So now I'm going to save this because we were returning the game results object here. Right. So I'm going to save that as JHC, so Jayhawks Chicken Hawks. And so now we have all the game results. So we have the Jayhawks Chicken Hawks. We can access it with the @ symbol. We can see team 1, team 2, and the predicted results that we got for each one. Then we can also, those methods that we created, we can do get winner on the Jayhawks Chicken Hawks, and it'll return us the team that won and their team object. And then we can also get winner percentage from the Jayhawks Chicken Hawks. It helps if I spell that right. And that returns us 61%, which is the exact win percentage. And so you could go out and create like a ton of different methods to pull out all the various things that you wanted to. You could look at the distributions of the two and what overlap. I don't know, a bunch of stuff that we did in the past that.
Yeah. It's nice to have all those things available. Yeah, it's nice to have those things available in case you want to do that stuff, or build a dashboard and show yourself the distributions and figure out, well, even though the Jayhawks have a 61% likelihood of winning, like what's the probability that that percentage is below 50%, right? Like you could, pull out all of those things and get a sense for what's under the hood of the simulation, so to speak.
Yep. So like these are the simulated values.
Simulated draws, yeah, right.
Yep. Cool. But it's kind of taking, and this was advice from a viewer, like why wouldn't we just create an S3 object to store the game results? Here you go. Here's how you can do it in S4. Similar ideas for S3 too. You can do it similarly with that. So now let's simulate a random game. Let's pull two teams at random and play them against each other. So we're going to create a new function. We're going to use triple dot notation, and all that means is we're going to just pass everything through, and you can enter as many values as you want. And we're going to throw that into this list here. So it's similar to here. Right here you can see we're calling random game, and we're just passing a bunch of random stuff here going into the triple dot. This is functionally similar to list. Like this, what's going on under the hood is we're basically doing this.
Yep.
It's a little bit funky to wrap your head around. I know we touched on it very briefly before, but that's essentially what it's doing. So then we get a list of the teams that are playing. We're going to randomly select two. Without replacement, that means that we can't select the same team twice. And then we're going to run a simulated game. But the nice thing now that we are storing all that game information is we can record all the stuff about the game itself. And, team 1, team 2, predicted seed. So we had a seed of 3.1 e to the negative 5. The game, game. The predicted results are this. We could throw this into a plot. I think we can do AB line, right? A is slope, and that's a slope of 1. B is 0.
Intercept is 0. I,
I mixed that one up. My bad.
yeah, I don't think that's what you wanted. I don't think that's what you wanted. You,
Let's
you
do.
could do like a hist of the difference between your two columns.
There we go. Here's the
Oh, there
line.
it is.
I know how to
Or
do
you could do
base
that.
R plotting.
There you
Thank
go.
you. But yeah, I think also
Hey.
the
Hey.
hist might be more interesting too. So then you could do a hist of game at pred results.
Column one.
$1
Column. Yeah.
minus game at pred results $2. Oh no, it would. Let's just pull
Yeah.
out the specific column
Yeah.
with double square braces. And here's a
Yeah. And now
histogram.
you
So
could
if you want
do
to see,
a b line v equals 0. So put it on the vertical at 0, which would be v, not v. Uh, now
oh,
you put that on the vertical.
it's like right here. So it's right
Yeah,
at the chunk.
you need to, yeah, you make it like red or something. But that's one way to then show the difference of each of your, 10,000 universes of simulated games.
Yeah, you can look at all that. But anyway, this is kind of a fun way to do this and kind of how you can start seeing like this is my like personal feel and it is I think it's probably mostly born out of just lack of experience, but I feel like S3 and S4 feel relatively similar in the like the using side of things. The writing and the creation of them definitely feels very different. Because with S4 you have to define much more upfront. I mean, we have structure in S3, but you can always just kind of add stuff to it and just kind of like, I want this actually, and add it in.
Yeah,
S4 is going to yell at you and say, no,
right.
not up in here. So
Not on my watch.
exactly.
Right.
But yeah, I'd be curious to hear what you all think. What are some ways that you think you'd be wanting to use S4? What are things you want to see in the future? What is an object class that you've heard of that you would maybe want us to look at next? And go from there. I think that means we're going to call it. As always, my name is Ellis Hughes, and you can find me on Twitter at Ellis_Hughes.
And my name is Patrick Ward. You can find me on Twitter at OSPPatrick and at Tidy_explained is where you can find the both of us on Twitter. Tidy.explained@gmail.com is where you can email the both of us on Gmail. Most people go to the YouTube channel, like and subscribe, drop their comments down below. That's probably the easiest way to get in touch with us. And as always, if you enjoy the work and you feel like it's made a positive impact on you as a R programmer and you want to contribute to our efforts, we do have a Patreon page, and we are always appreciative of whatever you may contribute.
Yep. Thank you all so much, and keep on exploring your world.